Okay, today we're going to start with chapter 6, solving systems of equations by graphing. Our objective for today, I can solve the systems of equations by graphing. And that's what we're going to do in that first example, the first problem. So what is a solution though? We need to know what a solution is for a system of equations. A solution is an ordered pair. So what ordered pair works for both equations? And one way to find out what that ordered pair is to graph. This is what is the solution of a system of equations? Use a graph. So we need to graph these. So remember, these are in the form y is equal to mx plus b. That's slope-intercept form. So y is equal to mx plus b. My b tells me my y-intercept, where I cross the y-axis. So on this first one, I'm going to cross that y-axis at 2. So positive 2. So I'm going to go up 2 and put a dot right there. My slope. So remember, the slope is what comes in front of the x. In this case, it's right there, which is an invisible what? So 1. And remember, we have to write slope as a fraction. So 1 is the same as 1 over 1. So I'm going to go up 1, right 1. I'm going to continue that until I form a line. So now I need to graph my other one. So my y-intercept is negative 2. My slope is 3. Again, write as a fraction, so 3 is equal to 3 over 1. And I'm going to go ahead and graph those points. So I cross my y-axis at negative 2. I'm going to go up 3, right 1. So up 3, right 1. Up 3, right 1. And I'm going to continue doing that. I'm going to draw my line through my points. So my answer, my solution, is where they meet up. Where do they cross? So they cross at this point right here. So if we look at that point, that's point 2, 4. So my solution is 2, 4. So that works for both those equations. Moving on to problem 2. So problem 2 is going to be similar. It says writing a system of equations. So that means we're actually going to write what the equations are. So scientists studied the weight of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same amount? When we do this, we probably want to put them in slope-intercept form. So again, remember that y is equal to mx plus b. So this first table on the left says alligator 1, the initial weight was 4 pounds. The rate of growth is 1.5 pounds per month. Alligator 2 has an initial weight of 6 pounds, and the rate of growth is 1 pound per month. So what this initial weight is, that's going to be our y-intercept. That's our b. Whatever this initial weight is, that's our b. The rate of growth is how much it's changing. Rate of change is the same as slope. So this is our m. So equation 1 is going to be y is equal to, so m, what my m is, so my m is 1.5 x, and then I need plus my y-intercept, plus my b, so plus 4. Equation 2, so for alligator 2, so y is equal to my rate of growth for alligator 2 is going to be 1 pound, so 1x, plus my y-intercept, my b, is going to be 6. What I want to know is I want to know where these two graphs are going to meet. When do the alligators weigh the same? So there's one little tweak we have to do, and we need to go through and we need to renumber our y-axis. So we're going to skip count. So this is going to be 2, 4, 6, 8, 10, 12. We don't really need to go down. We're just going to use that top one. So let's go ahead and graph. So on this first one, my y-intercept is 4. So I'm crossing at 4. My slope is 1.5. Again, I need to write that as a fraction. So 1.5 as a fraction is the same thing as 3 over 2. So I'm going to go up 3. Again, remember I'm skip counting. So 7 is between 6 and 8, and then right 2. I didn't skip count on my x, so I still need to go over 2. And I'm going to continue to do that. So up 3 puts me at 10, right 2. Up 3, right 2. And again, I can go backwards too. So down 3, left 2, down 3, left 2. So I went ahead and graphed for alligator 1. I need to do the same thing again for alligator 2. So my y-intercept is going to be plus 6, so positive 6. My slope is 1. So again, 1 as a fraction is 1 over 1. So I'm going to go up 1, so to 7, right 1, up 1, right 1, up 1, right 1, up 1, right 1. We'll go ahead and make our graph. So where those meet up, right there, I need to see what that point is. So it's 4, 10. So my solution is 4, 10. So what this means, that at 4 months, both alligators weighed 10 pounds. So that's our solution. So at 4 months, that was how many months they weighed the same amount. Go ahead and turn your paper over to the back. Problem 3. So systems with infinitely many solutions or no solution. So the first one says, what is the solution of each system? Use a graph. So if you look at that first, that's not in slope-intercept form. Remember, that's in standard form. And we can graph in standard form by finding our intercepts. So I'm going to set up my intercepts. So 2y is equal to 2. And then negative x is equal to 2. That means y is equal to 1 and x is equal to negative 2. So I need to go ahead and graph that one using those intercepts. So on my x-axis, I'm going to negative 2. On my y-axis, I'm going to 1. We're just going to put a few more points on here. And I'm going to go ahead and graph that line. So I'm going to go ahead and graph the second one. So my y-intercept is 1. So at 1, I'm going to put a point there. My slope is 1/2. That's already a fraction. That means I'm going up 1, right 2. So up 1, right 2. Up 1, right 2. And then I'm going to go ahead and graph that. So I've gone ahead and graphed that. This is the same line. If it's the same line, I can pick any point on that line, and it's going to be a solution for both of those. So this is infinite solutions. Our second example down here. Both these are in slope-intercept form, so it should be pretty easy to graph. So the first one, my y-intercept is 2. My slope is 2. So 2 is equal to 2 over 1. Means I'm going to go up 2, right 1. Down 2, left 1. Down 2, left 1. Remember, I can always go backwards. So this is my line right here. The second one, my y-intercept is -1. So on my y-axis, I'm going to go down to -1. My slope is 2 again. So 2 is equal to 2 over 1. So I'm going to go up 2, right 1. Up 2, right 1. Up 2, right 1. Down 2, left 1. And then I'm going to go ahead and graph this. So if I look at these, will these lines ever cross? That's the question. No, they're not going to cross, and we call those parallel lines. So if they're parallel lines and they never cross, there is no solution. So lastly, your guys' homework is going to be on IXL. It's going to be U2. Also, on page 369, you need to do numbers 46 through 57. Again, that's mixed review over stuff we've done in the past and kind of intro to stuff we're going to be working on next class. Go ahead and get started.